Yeah. Again, we came up with another new problem from Pathfinder book, and this problem is taken from challenge your understanding in the kinematics section. Okay, let us start the problem. Starting from the center of a circular path of radius capital R, a particle P chases another particle Q that is moving with a uniform speed V on the circular path. The chaser P moves with a constant speed U and always remains collinear with the center and the location of the chased Q. On which path will P eventually move, and how long will it take to reach on this path? Consider the cases u less than v, u equal to v, u greater than v. If the speed of the particles are v is equal to 4 meter per second and u is equal to 8 meter per second, and radius of the circular path is 84 meter per second, how long P will take to reach Q? This is the question, and this is the diagram related to that question. So just see, copying this for the safe side. So we have to solve this problem now to see the solution. Directly proceeding to the solution. This is the diagram. I am taking the particle P at the origin O, and this point O is the center of the circular path of the particle Q. Okay, the particle Q is starting from this point as shown in the diagram. This is the point from where the particle Q is starting, and the particle P is starting from the origin with its velocity directed towards the capital Q. So in this manner the particle P is starting. Okay, so the particle P chases the particle Q, and it always remains collinear with the center. Always remains collinear with the center. So this condition is given in the problem. And what is given? The particle P here, the particle P always moves with a constant speed u. The particle P always moves with a constant speed u, and it has two velocity components. You can see the particle P has two velocity components. One velocity component is directed towards the particle Q, so which is called as radial component of velocity, that is denoted as v dash. So the v dash is the component of velocity of the particle P, which is in the radial direction, and it is pointing towards Q. Okay, so next there is another velocity which is perpendicular to the radial velocity, that is velocity v, and this velocity v of the particle is perpendicular to the radial velocity, and this velocity v is parallel to the velocity of the particle Q. So you can clearly notice that points in the diagram. Okay, so if you observe the situation carefully, the particle P finally chasing the particle Q. That means the both particles must have same angular speed. Both particles must have same angular speed. So that is the most important observation. You have to observe the diagram, you have to read the problem carefully, then finally you will come to that conclusion that the particle P and particle Q both are having same angular speed. So that most important point is there. So that observation, the particle P and particle Q both have same angular speed. So based on this observation, we can simply write like this: the velocity of the particle P, which is perpendicular to the radial velocity, so that is a small v, divided by the radius, that is small r, is equal to the velocity of the particle Q, that is v, divided by its radius r. So in this way we can write this point. So what is the next point here? Next, we have to find the time taken by the particle P to catch particle Q. Time taken by the particle P to catch particle Q. So I want to compute the chasing time. Computing time taken by particle P to chase particle Q. So this time we have to compute. So in order to compute that time, let us see the diagram once again. Let us see the diagram once again here. So I am going to erase some unwanted things in this diagram. So to get the better clarity. So see here, I am going to take only the required parts of the diagram. So from here to here, this is the radius. So the particle will travel along radial direction with velocity v dash. So I will show you separately here. The particle P will travel in radial direction. So this is suppose the particle Q, and it has velocity in this direction. And see here, the particle P is directed towards the particle Q, and its velocity in this direction is v dash. So this is the radius. Of course, up to here it is radius, and the particle P travel a small distance, so that is dr in the direction of Q. So this diagram is important. From this diagram we can write the dr value. Dr is equal to the speed of the particle in radial direction, that is v dash, into time. So let the time be dt. Okay, but we already know one thing, the particle P is moving with constant speed. As the particle P is moving with constant speed, you can simply write u as square root over v dash square plus v square, v dash square plus v square, and we already know v by small r is equal to capital V by capital R, and from this we can easily find the small v value. The small v is given by small r divided by capital R into capital V. So this is small v value. Okay, so you can plug this value in above equation and see. So u square is equal to v dash square plus v means this term we can directly substitute here, r square divided by capital R square into v square, and you can take this term this side, u square minus r square divided by capital R square capital V square is equal to v dash square, v dash square. So this is the value of the v dash, and v dash is finally given as u square minus small r square divided by capital R square capital V square. This is the v dash value. Now we can put the v dash value here in this dr value. So this is the small distance traveled by the particle P along radial direction towards the particle Q. So that dr is equal to v dash. What is the v dash value? V dash is this much, and we can directly put the value of v dash here, and you can u square minus and small r square divided by capital R square into v square into dt. So this is the thing we are getting. You can send this term this side, and dr divided by square root over u square minus small r square divided by capital R square capital V square is equal to dt. So this is the thing we are getting. Now we have to integrate this by taking the proper limits. So here the small r is changing from 0 to capital R, because whenever the particle P is catching the particle Q, the small r value is equal to capital R. So this limits are taken like this: u square minus small r square divided by capital R square to V square is equal to. So we have to integrate this by taking the limits of time. Time starts from 0, and capital T is the time at which the particle P is catching the particle Q. Now, so we have to write this, we have to integrate this. What is the integration of this? So we can integrate this carefully by taking this common. So you can take this common. So you can take this V by R common, and what we are getting is V square by R square into R by V u whole square minus here R square is equal to, this is the time t after integration we are getting this. Let us see this one. This is R by V integration 0 to R dr divided by square root over R u y divided by V whole square minus R square is equal to t. Now integrating this expression. So what is the value? Sine inverse small r divided by R u divided by V. So the limits running from 0 to R. So the value of t is given by R by V into sine inverse. You can put the value of R u by V minus 0. So this R can be cancelled out. So t is equal to R by V sine inverse V by u. So this is the time taken by the particle P to catch the particle Q. Okay, so one segment is over. Next, on which path will P eventually move and how long it will take to reach on this path. So how long it will take to reach on this path means time. We have computed time and we have to discuss these cases. But we have to know what is the path traced by the particle P. What is the path of the particle P eventually move? So we have to find the path of the particle P that finally moves. Now we have to find finding the path of particle P that eventually moves. So we have to find the path of the particle P that eventually moves in the process of catching the particle Q. So how to find this? So let us see, again we have to consider the diagram. I will try to figure out again we have to consider the same diagram. I will remove some unwanted parts in the diagram now. So we have to take only the part that we require here. So now I am removing this velocity components also because I don't require this now. So this is the velocity components. So now see here, I can take this particle P and x comma y be the coordinates of the particle P. Let us take x comma y be the coordinates of the particle P, and see this this is the situation, and this particle P is the particle P coordinates are x comma y. The particle P coordinates are x comma y, and this is y, and this is x, and this is the radius r. So you can simply write r square is equal to y square plus x square, because it's a right angle triangle here. So this is from point O, this is the particle P, and we know already r value. We know already this r value because we have already computed. So this r value we can give. So this is the speed of the particle P, which is parallel to the particle Q. So now we can write v by small r is equal to v divided by capital R, and small r is equal to v into capital R divided by capital V. So this is the situation. This is an intermediate situation, but this is not the case that we require. We require the eventually what is the path followed by the particle P. So that path we require. Whenever we consider the situation where the particle P is catching the particle Q, at this instant the small v, that means this v value becomes u. So why it will becomes u, I will show you. I will show you with clarity here. Just see, and this is the situation. So now you can take this situation here. Suppose let us see the situation maybe like this. Here the particle P is, suppose it is catching the particle Q here somewhere. It is catching particle Q here somewhere. Maybe it's catching in this way. At this point, whenever the particle P is catching the particle Q, you can see one important point. This is particle Q and this is particle P. Particle P velocity will finally coincides with the velocity of the particle Q, because both particle P and particle Q have same speed at this point, same speed. That means in the place of small u, small v, we can write u. Okay, so now we are writing, because it becomes finally parallel to u. So small r is equal to u r divided by capital V. This point is very important. The speed of the particle P, which is parallel to Q, will becomes u when it meeting the particle Q. When particle P is meeting the particle Q, means it is chasing the particle Q. At the point whenever it is chasing, this is the situation. You can plug this value here and we will get the equation of the path traced by the particle P. X square plus y square is equal to u r by v whole square. So this is the equation of the path. Equation of the path of P. So this is important, and you can clearly see this is a circle equation. It is the equation of circle, concentric with circular path of a particle Q. The radius of particle P is you can see the radius of the particle P, radius of the circular path traced by the particle P is that radius u r by v. Radius of the particle P is u r by v. This is the radius of the path traced by the particle P finally. Okay, and we have to discuss the cases also here. Let us see how to discuss the cases. So if you take these cases, these are the cases that we have to discuss. So let us see these cases. These are the cases that we have to discuss. Now we are going to discuss these cases and paste in. Now see here, first case, u less than v. In this case, let us take this one. U by v is less than 1 and u r by v is less than r. That means, so radius of particle P is less than radius of particle Q. radius of particle P is less than radius of particle Q, but both are moving in concentric circles. That is the point. Next, if u equal to v, then in this situation u by v is equal to 1 and u by v into r is equal to r. That means radius of particle P is equal to radius of particle Q, and when u greater than v, then u by v is greater than 1, then u r by v is greater than r. That means radius of a particle P is greater than the radius of particle Q. So these are the cases. Okay, so that cases also we have discussed. Next segment of this problem is finding the speed for the given values. If the speed of the particles are v is equal to 4 meter per second and u is equal to 8 meter per second and radius of the circular path is 84, how long the particle P will take to reach particle Q? This is the thing that we have to find. You can easily find because you already know the formula now. We can use this formula to calculate that. Okay, I am using the same formula now. Yeah, here I am pasting it. Now let us see the part B solution of this problem. So particle V velocity is given here. Particle B velocity. What is the particle velocity? Is 84. Yes. V is 4 and AU is 8. R is 84. So this is the given values and we have to find the time. T is equal to R means 84 divided by V is 4. Sine inverse V is 4, U is 8. So T is this is getting cancellation here 21 times and sine inverse 1 by 2. Sine inverse 1 by 2, that value is pi by 6. So this is 7 3s, 3 2s. So 7 pi by 2 seconds. So this is the time. So if you want to calculate, you can also calculate that pi value, 7 pi divided by 2 seconds. That value comes out to be around 11 seconds approximately. Approximately in 11 seconds, the particle P will chase the particle Q. Okay. So this is the answer for the question given. So this is taken from Challenge Your Understanding Pathfinder. Okay. Bye students.